Okay, so let's start with today's class. The last time that we have been discussing about the singly linked list and also what are the elements or what are the properties present in the linked list. As you know, the linked list has the two segments. One is to store the value and the other one is to uh, used to store the memory address of the next node or the pointing the value of the node which is stored in the next node. So this is basically is all about the introduction of the singly linked list. Now today we will discuss about the applications of the singly linked list with the help of the algorithm and the certain videos. So let's start with the first video of today, that is how the linked list can be created in the form of a program. Please mind you, you have to just prepare the method part or the algorithm part. You did not have to prepare the whole program, and also the practical part is not required because the practical part is not there in your syllabus. So only thing is that you have to just know how to prepare a method corresponding to each and every application of the linked list, and also you have to learn how to prepare the algorithm. In your ISA question papers, if you see in the part 2 section C, there is every year there is a linked list application based question where mostly your linked list has already been created. Okay, what you have to do is that related to the created linked list, you have to perform certain application by the virtue of writing any method or by writing any algorithm. Here the videos that I'm going to showcase today is mostly of the program based, so you'll get to see the program part, how the program part need to be written. Okay, apart from that, uh, like the different set of the algorithm that I will share with you after the completion of today's class. Okay, so let's start with the first video, that is how to create the single linked list in the here you will see the coding and the algo part. Okay. Okay.
Can you increase the volume?
Yeah. The first part, as you can see, that we will be creating this linked list. So what all elements we have to keep in mind, please make a note of this properly.
Each node has data and holds next node adjacent to it. The last node has next node as null. It signifies end of linked list. Let's see demo below how this list is created. Initially, head node points to null, because the list is empty. Let's create first node which has data as 10, and next node points to null. In order to hold nodes one by one, first we make head point to node 10. Here list contains one node. Let's create second node having data as 8, and next node points to null. Let's connect head node to second node, by pointing next node of head to second. Similarly, we create and link third and fourth node as demonstrated. That is, second node points to third node, and third node points fourth. As fourth node is last node, therefore its next node points to null. Let's create same linked list through Java code. In main method of singly linked list class, we create linked list demonstrated in slide. That is, node with data as 10 points to node 8. Similarly, node 8 points to 1. And node 1 points to 11. And finally, node 11, being last node, points to null. Also, node with data as 10, being the first node, is the head node. Let's create a list node by name head with data as 10 as its first node. Therefore, it has integer data as 10, and next node is null. Similarly, let's create other 3 nodes, as demonstrated. Where second holds data as 8, third holds data as 1, and fourth holds data as 11. Currently, all nodes next points to null. Let's modify next of each node to attach them together. Head.next points to second. Similarly, second.next points to third. And third.next point to fourth. Thus, we created 4 list nodes and made them connect together to form a linked list. So friends, this is how linked list is created in Java.
Okay, before going the further elaboration of this video or to replay this video, let me just discuss about certain elements which you have to understand. Firstly, there are certain elements which you can see. The first thing which has been done is that in this particular program, as you can see, that a class has been created as a simply linked list. Okay, and you have certain like list node. As you can see, this list node is nothing but the predefined class which is already present in the Java compiler. Okay, but mind you, this list node does not have any definition which is defined inside the Java compiler. So inside this, what happened, if I go text by text, this is basically designing the structure that how does the node look like. If you remember, I have drawn a rectangular box which is segregated into 2 halves, where the left hand part indicates the value and the right hand part indicates the address part. So this part, as you can see on the top of this part, this is basically designing the structure of the node. As you can see, this dot data, what they have done is that they have created a constructor list node, okay, a parameterized constructor that will hold the value, and this dot data is equal to data and this dot next equal to null. That means considering that the very first node is created which does not have any value and which does not indicate to any other node to the next. So basically, every time if you remember, if you try to understand that the main part, that this part only execute on the basis of this, like as you can see that you are storing the value of 10, 8, 1 and 11. That means first you have to create the node. If you don't create the node, then where will you store the value? So first and the foremost thing is that with the name of this object, head, second, third, fourth, with the name of this object, what is done is that you are naming individual node every time which is created, and after you create that individual node, what you are doing is that you are storing the value into the node, into the value part of the node, that is the data part. That is this dot data equal to data, which means when the first node is created, okay, try to understand, if the first node is created which is known as the head node, that means in the data part you have the value 10 and the next part is known as null. That means the first node is created, in the first node you have a value 10 and the in the pointer part, it is null because your first node is not indicating to anyone else. Okay. Again, the second node is created. In the second node also, you are storing the value 8. But again, the pointer part, that is the link part of this particular second node. Okay. What is happening? It also have the pointer value null. That means the second node is also not indicating to any other node. So this is basically with the help of the structure of the node, what you have done, you have created 4 nodes, and in the 4 nodes, what you have done, you have stored certain value. Try to understand with the help of this design structure of the node, what you have done, you have basically stored 4 value inside the node. That is basically what you mean. Okay. Now, what comes the next? Now, all these nodes need to be interconnected. Okay. How will you connect? You will connect with the help of the next keyword. The next keyword is the keyword which identify the address of the value which is stored in the next node. Try to understand. It identifies the address of the value which is stored in the next node. So what it is happening in the head node, head.next indicates what? The pointer or the link part of the first node. Okay. Let me do one thing. If I can draw the diagram and show you in the better way, that will be a lot more easier. Okay. Let me elaborate this part. Now, basically in the program, as we have seen, we have created 4 nodes. Okay. So let me design 4 nodes out here. Okay. One, 2, 3, and 4. So these are the 4 nodes which has been created. Now, in the first part of the code, if you remember, first we have created the node and we have stored the value. So how did we store the value? Okay, that means this value, this particular node consists value 10. Okay, this node consists the value of 10. This contained maybe 8. This value contain 7, and this contain, let's say, 11. Okay, so that means you have basically stored the value, but as you know, the second half of the node is nothing but the pointer of the next node. Try to understand the pointer of the next node. So that means if the name of the first node is head node, the head node is pointing to the value of the next node. So how will you define it? Head dot next equal to second. That means the second node is indicating this, the value, the second node where the value has been stored. This value had to have some memory address. Now this address is represented by head dot next. Okay. Now in the third node you have certain value. It also have some memory address. That is 7 have some memory address. So how will you indicate? Second dot next. The fourth node have some memory address for the value 11 which has been stored. How will you indicate? Third dot next. So basically with the help of the next, it is identifying the memory address of the value which is stored in the next node. So this is what you call the function of the next keyword. Okay. Yes, if you want to ask anything. as you can see here, the second value is indicated by head dot next. That means the first node memory address part. Third is equal, third value is indicated by second dot next, which means second node memory address part. Okay, and this is the data value part where the values are stored. Okay, try to understand this part as the comment lines are also given. The first part which you need to jot it down very carefully, I want you to note it down also. The first part is the designing of the node, that how you are designing your node which is to be used in the linked list. Now in the node, basically you have two parts. What is the first part? The first part is the data part. Now if you see, there is a access specifier used as a private. Why private? Because each node is responsible to store its own value. No other node can access the value. If you can try to recapitulate in the previous concept, in when I was discussing the differences between array and the linked list, if you remember, in the array part, what happened, if you insert any node or if you delete any node, the values tends to change their memory address. But in this part, in the linked list part, the values are not changing their memory address. So that is why what it is said, if your certain value, suppose 8 is stored in the second node, okay, the value of 8 will remain in the second node until and unless you don't delete the second node. Okay, if you insert any other node in the middle, try to understand, if you insert any other node in the middle, then what will happen, that is the value 8 which is present in the second node will remain in the second node. The new node will get or will acquire the new position. So this is what you call the structure of the, and those things we will discuss when we will discuss about the applications of the singly linked list, that is insertion and deletion, that we will discuss. But as you can see, that is the data is always kept private. Why private? Because each node is responsible to store its own value. No other node can access any value. And what is the next part? Least node next. That means it will store the memory address of the value which is stored in the next node. Okay, and both has been kept as a private. I repeat, both the class variable has been kept as a private because these two are limited within the node itself, no matter how many number of nodes you create. Okay, the second
Admitted.
somehow it got disconnected. Anyways, so
Sir, last line. Repeat
yes.
last line. What you were saying.
Repeat
Yes.
the last part, please.
Yes, the last line what I was discussing, that is each of these variables, as you can see, is private accessed because no matter how many number of nodes you have created, but every node, each and every node is responsible for their own set of the elements. Suppose the head node, which is considered as a first node, in the first node you are storing the data value and the memory address of the next node. Okay, so the second node or the third node cannot interfere in the head node. Okay, so that is why, like if we made it public, then what is the accessibility of the public? Any node can interfere with any other nodes. But in this case,
Yes,
we are not doing that. What we are doing is that every node will restrict their own set of the value. What are those values? Number one value is the data value, and the second part of the node is the address, the memory address of the next node. Okay, so that is why they has been accessed as a private type. And in this part, as you can see, the constructor has been created, a parameterized constructor has been created. Now inside the parameterized constructor, what we have done, we have given a default value. Now we have discussed this these operators while discussing the memory, while discussing the method. Now, what does this represent? This dot data, this dot next, it represent nothing else but the class variable which is storing certain value. So your this set of the variable, that is the class variable, has been stored with some default value inside the constructor. So this is basically the outline design of your node. Okay, in the main function what we are doing is that we are creating certain object, and these objects are nothing but the name of the nodes, that is head node, second node, third node, fourth node, as many number of nodes you are creating. Now the question comes up, every time we are creating this node, why can't we do this in the form of for loop? Okay, so in this case, if I would like to tell you, we cannot do it in the form of the for loop for two reasons. Number one reason is that, firstly, the values which are getting stored are not in a contiguous memory location. Try to understand, this is linked list, this is not an array. Okay, yes, what you can do is that for storing the value, you can use for loop only for storing the value into the node, nothing else. I repeat, you can only use the for loop to store the values inside the nodes. That is the only purpose where we can store the, where you can use the for loop. But to link each and every node together, you cannot use the for loop. The purpose is that, as you can see here, the next command is holding the memory address, and this memory address is actually the random memory address. Okay, and random memory address means it cannot be in a sequence of incremented order or decremented order. So that is why what it is done is that the linking has to be done manually in the singly linked list part. But yes, if you have created a node, then what you can do is that you can store multiple values in, not multiple values, means you can store the values into the multiple nodes with the help of the for loop. So this is basically the outline. As you can see, that this is how your single linked list is actually created. Now the thing is that, obviously, once we create the linked list, we will look forward to get our value to be printed. Okay, so for this we will see the next.
Hello friends. Welcome to my new data structures and algorithms in Java tutorial series video. Friends, in our previous tutorial we saw how to create a linked list in Java. In this tutorial we will discuss how to print elements of a linked list in Java. Let's print elements of linked list shown in slide. Below is the algorithm for this. Initially, output is empty. We will create a temporary node by name current. Initially, it points to null value. Let's execute below algorithm and see how it print elements in a linked list. First step is to make current node point to head. Second step is to execute few steps in a while loop. The while loop executes till current node is equal to null. It simply means, when current node becomes null, the list has reached its end, and there are no more elements to print. Currently, current node points to head, which is not null. Thus, statements in a while loop executes. First statement prints data of current node on console, and the output displays as 10. Moving to next step. Here currently, current node points to head, and current's next points to second node. Second statement assigns current's next node to current. That is, it traverses current node to second node.
Now, normally while using the looping concept, you all generally knows that we Am I audible, everyone?
Yes, sir.
Yes, sir.
Okay. Now I don't know, somehow it's showing no internet access. So, okay. Anyways. Okay, as I was telling you that normally while using the looping concept, we have generally see that we use the modification format in the form of I is equal to I plus 1, or maybe C is equal to C, or maybe C plus plus, or A minus minus. This kind of generally mathematical modifications we have seen. In this part, as you see that each of these nodes are actually located in the random memory address. So what happened, the sequence of the modification can be irregular. Suppose this is located at 1000, this is located at 2000, this is located at 2050. That means the sequence of the memory address of each of this node is irregular. Since it is irregular, so this is mathematically cannot be implemented. So what can we do? The only way of identifying from one node to the other node is using the next operator, because only the next operator can link up with the other node and store the value of the memory address, and that is why this part is happening. So what happened, current dot data means current node dot data, that is the value which is stored. Once it is printed, what happened, this current variable is modifying to the next value. How? Current dot next. And all, as we know that the next is the memory address of the value which is stored in the next node. So that memory address will get stored into the current part. So that is why initially when this was the current, now the current has been moved into the this part, because out here current dot next is actually indicating this second node. That is why current is equal to current dot next. Okay.
Now again it checks for while loop condition. Current node points to second node, which is not null. Therefore it again executes statement in a while loop as demonstrated. Output now becomes 10 and 8. And current node now points to third node. Similarly, now again it checks for while loop condition. Current node points to third node, which is not null. Therefore it again executes statement in a while loop as demonstrated. Output now becomes 10, 8 and 1. And current node now points to fourth node. Once again, it checks for while loop condition. Current node points to fourth node, which is not null. Therefore it again executes statement in a while loop as demonstrated. Output now becomes 10, 8, 1 and 11. And current node now points to currents next, which is null. That is, element next to fourth node is null. This signifies that list has reached its end, and there are no more elements to traverse. Now when it checks for while loop condition, current node points to null, therefore while loop condition fails, and loop terminates. Thus, through this demo we saw how to traverse complete list one by one, and print its element on console.
Okay, so what we will do is that we will move to the next link, as there is some other part of this video also which need to be discussed, cannot be completed. Yes.
So what is this current?
Sir, current is a temporary variable which is indicating to the present node.
Okay.
Present node. Every time each node is being traversed, if you have to visit the third node, if you don't visit the first node or the second node, you cannot read the value of the third node. So every time the present node is traversed, that present node is represented by current. So when you are starting, which node is the first node that you are traversing? That is head node. That is why current is equal to head. Okay. And two things are being used. Please keep this in mind. Current dot data and current dot next. Current dot data means what? Current dot data means the present node where the value is stored, and current dot namespace, the memory address of the value which is stored in the next node. So these two elements you have to keep in mind every time. Okay.
But so first time we are storing the value of the node.
First, sorry.
Yeah, when we are current equal to head, then we are actually storing the value of the head, not
The value storing part has been done in the previous program. This is already the linked list is created. We are just printing the value. Here we are not inserting the value in the linked list.
I mean to say, sir, in the current storage, we are initializing the head value there. Current equal to head, then the
current equal to head means the head node, and head actually represent the value part of the first node, not the address part of the head node. Head represent the value part of the first node, not the memory address. If you, I hope you can see my arrow direction.
Yes.
When I am representing head node represent the value, not the memory address, because this memory address is indicating the next node. Then how can this becomes the next node? Clear?
Okay, so this dot data is a function. Dot
What?
data.
No.
Then?
Acha, we'll come back in the next link. I'll continue with this.